Right, so this is for Module 4, Lesson 17. This is the problem set. So remember, the problem set is very similar to the homework, but it has different numbers that are being used, but this can be used for examples. So I'm looking here at number 1. They have kind of done an example here for us with the models, but I'm going to work on 1A. It does tell me to draw a strip diagram and a number line to solve this. So you need to make sure that you do draw that and use the number line. Reminder, if they tell us to use something, we use that, because if we take a test and they tell us, we need to make sure we're following those directions so that we can get full credit on our test scores. So when I'm looking here, if, sorry, not if, but we are starting with 4, so I drew my number line already out and we went all the way to 4. And we are going to divide that into a half. So if I think about this, I'm going to pretend like this is just one whole. We're going to pretend like we went from 0 to 1. If I cut it into half for one whole, we're going to end up with 2 halves. So now we're going to treat each of our halves here as a whole. So if I cut it in half again, I'm going to end up with another 2 halves. Same thing here. So when I cut that in half, I now have 1 and 3 that we have on our number line, unless you've already filled that part out. Now I can cut into half again for each one. And we would have a half, 1 and a half, 2 and a half, 2 and a half, I did thirds, and 3 and a half. So if I look here, I can make a total of 1, 2, 3, 4, 5, 6, 7, 8 halves. So if 4 is a half, what is a whole? Then we have 8. So 4 divided by a half would equal 8. And I know this might be a little confusing. It'll probably be more understood this time, in my opinion, with you just doing the computation than the models. But again, we do need to do the models because Eureka is wanting us to, and there's probably going to be students who actually understand the modeling more than they do the computation, and later on will feel more comfortable with that computation. So let's look here at part B. They want me to start with 2, so I'm going to, let's make my number line a little bit lower. So 0 to 2. I'm going to go ahead and draw my strip diagram. I kind of like to attach it to the number line so then I make sure everything's kind of set up right. And if I think about this, if I pretend that this whole thing is a whole, if I cut it into fourths, I would have 4 total sections. So one whole would equal 4. So I would start here as 1 and here as, make sure I'm saying that right. Yeah. Sorry, I'm going a little ahead of myself. So we're going to start here and we're going to cut each one into a fourth because we're going to actually want to end up with 8. So we would cut those again. So we end up with 0, a fourth, 2 fourths, 3 fourths, 4 fourths, which equals a whole, 1 and a fourth, 2, oh sorry, I am jumping ahead of myself again, 1 and 2 fourths, or a half. Same thing here, this could also equal a half. And then 1 and 3 fourths. When we get to 1 and 4 fourths, that equals 2. So we should be saying that there are 4 fourths in a whole. In 2 wholes, we're going to have 8 fourths. So my answer will be 8. I know it's a little confusing. I'm struggling with it a little bit as well. So if students are struggling with this, have them reach out to their teacher. The modeling part's probably going to be the biggest struggle here. The computation, in my opinion, this time is going to be more of the easy route. So I'm going to now move on to part 2. On part 2, it just says divide, then multiply to check. they're doing it a little different here with Eureka, and I'm going to show it that way, but then there's also another method that we're able to use, and I'm also going to show it that way. I'm going to prefer the second model, and I believe Miss Moffat is too, but we are going to show both models. So on part A, we have 5 divided by 1/2, and is what they are wanting us to do is take our 5 times 2, and we're going to 5 and our 2, and we're going to want to multiply those together to get 10. So they're just kind of having us work backwards here, and we'll take 5 times 2 equals 10. So then we'll say 1/2 times 10 equals 5. To go and check with our multiplication. And they're doing it this way, but then it's not like, I don't know how to explain it. The way that they're having us set it up, they're just kind of having us think of it backwards this way without using the steps that I'm fixing to say. I feel like it's a little confusing doing it this route. So if we can remember, and this is what I'm going to use from here on out, to use keep, change, and flip, then we're going to be good to go with our division. So I've told my students multiplication is my favorite because I don't have to change anything. I just keep it, we multiply. Where addition, subtraction, we have to find our common denominators before we can add or subtract. And with division, we use keep, change, flip. So we're going to keep the first number. So we have 3. We're going to change division. We're going to change division to multiplication, and we are going to flip the next number, whether it's a fraction or a whole number. So instead of 1/2, we're going to do 2/1. When we have 1 as our denominator, that can actually cancel out. And we do 3 times 2, which is 6. Again, it's like, I think they're implying that the students, in a sense, should kind of know this. But if they use the keep, change, flip, it's the same thing. They're just having them go here and take our whole number, multiply it by the denominator, or I guess the first one there, multiply it by the denominator, and then we're just dropping the 1. But that way they can see what's going on if they use keep, change, flip. Another thing I like to tell the students is if I'm starting with a whole number in 5th grade, then my answer is going to be a whole number, where later on we'll have something like 1/2 divided by 3. And if I start with a fraction, I'm going to end with a fraction because some of them are going to get mixed up here. So I have 4 divided by 5. So I'm going to keep my 4, change my division to multiplication, and flip my 1/5 to 5/1. Again, my 1 is my denominator. I can lose it. And I now have 4 times 5 is 20. So again, if I came here and I did this and I did check with multiplication, I would do 1/5 times 20, which would equal 20/5, which would equal 4. So if I check it, I should end up with my whole number there. And you should be checking it because it does tell us to check it here. I know I didn't check it on B, but I was just more wanting to focus on those keep, change, flip steps. Students do not mix this up with KFC. Students will do it all the time. I tell them to think of it this way. If they try to change it, they'll say keep, flip, change, and I ask them how are they going to flip that. The division symbol looks the same if it's flipped. That's what I just tell them. So they need to try to remember that it's KCF. So I'll do one more. Let me look at G. So I'm going to keep my 8, change my division to multiplication, flip 1/3 to 3/1. I can drop the 1 since it's on the denominator. 8 times 3 is 24. So 24 would be my answer. To check it, I'm going to take my fraction, 1/3, multiply it by 24. 24 times 1 is 24, so over 3. And we divide, I get 8, so I end up with that whole number that we had there. The rest of it is word problems. Again, if they need help, just have them reach out. I know the modeling is going to be a little difficult for them. I do apologize if I didn't explain that well enough. This one is fairly new to me. If you need a better explanation, let me know and I will sit down and try to figure out another way to try to explain it. I do not mind doing that. And hopefully this does help though. They can also go ahead and they can use that keep, change, flip on here with the models and go and check themselves to see what that answer is supposed to be so that they know how many boxes they are supposed to have. But hopefully this helps out. If not, reach out and I will make another video. Thank you.